Hello everyone, welcome to AE410 laboratory session. This is the wind tunnel we will be using in the experiment. Today we'll make pressure measurements with the use of a pitot-static tube. This is the yellow tunnel in the Rüzgar building. This is the fan in the tunnel. This is the control unit of the tunnel. We turn these on. They're already turned on. We control the frequency of the fan by this unit here so that we can control the flow velocity in the test section. Let's see the test section. This is the test section where the probes are placed. As you can see, any holes are covered so that no interference to the test section is present. This is the inlet of the tunnel. As you see, this is a suction type wind tunnel with a bell mouth inlet shape.
This is the pitot-static tube. It is supported by a holder outside the test section in order to avoid excessive vibration on the tube. The tip of the tube should be aligned with the flow velocity vector. In order to do this, a laser alignment tool is used. Let's have a closer look to the pitot-static tube. This is the total pressure port, and this is the static pressure port. These ports should be connected to the pressure scanner. Pressure scanner is a differential pressure measurement unit. It has 32 channels where we can connect silicone tubes. It directly collects pressure data. It converts pressure data to voltage output and then converts the analog signal to digital one. Then transfers it to the data acquisition instrument. This is the data acquisition instrument system. The data acquisition instrument system allows the user to configure acquisition parameters such as sample rates, averaging, etc. with the help of the software provided with the system itself.
And now we can begin collecting data. This is the interface of the measurement program. Before collecting data, we re-zero the data acquisition system. Let's do it together. We press this, and then we heard a clicking sound. We wait for a few seconds. There's a clicking sound again. And now calibration is done. It means all the pressure values in all the channels oscillate around zero as the tunnel velocity is zero. This means the data collected should be reliable. And then we control the frequency of the tunnel by that control unit so that the flow velocity is not zero in the tunnel. We wait for 30 seconds after changing the frequency and then start collecting data by pressing this on button. We then collect data and save it. Now that the tunnel is running, we should wait for a few seconds for the velocity profile inside the test section to develop perfectly. Then after waiting for like 30 seconds, we can start collecting data. As you can see, the pressure values in the third and fourth channels increase now because the pressure ports are connected to those channels. So this is basically it for the whole procedure. We increase the frequency of the fan and then collect data and then save it for further post-processing operations.